Welcome to all in this video lecture on information theory and coding. So in this video lecture I will discuss about the concept of CRC algorithm. Okay, so CRC algorithm is actually used for the error detection. Okay, so this method is actually a error detection method. Okay, error detection method. Okay, so here actually in CRC method there is two process. One process at on the transmitter side. So in the transmitter side we have to perform four operations. Okay, if you perform these four operations, then we will generate a CRC. Then we generate a CRC. So the question is why we generate the CRC. Okay, so the answer is you know your original message. So this original message is mixed with CRC. Okay, so original message is a combination of message plus CRC. Okay, so this data, this complete data to be transmit. Okay, so this complete data to be transmit on the transmitter side. Okay, and if you transmit this data, so that means on in the receiver side we receive the same message, your original message and also the CRC. Now in the receiver there is some process. So using this process we have to find out this received frame. This received frame is correct, means correct or corrupt. Okay, means how many bits are corrupt and which bit is corrupt, everything we get this information. Okay, so now we come to all these steps at the transmitter, how to generate the CRC, and we also discuss how to check the frame, this frame is correct or something corrupt. So first step, you have to find out the how many bits in the divisor. Okay, so some divisor bits you have to find out. Okay, and after that if you say in the divisor the number of bit is n, so we take n minus 1 value and this n minus value to be included in the data bit. Okay, so that means your message plus some data. So this data size, this data size is n minus 1. Okay, so this is the complete message. Then we perform a division operation. Okay, then we perform a division operation, and after the division operation we get a reminder value. Okay, so this reminder value is known as a CRC. Okay, this reminder value is known as CRC. Then I already tell you in the transmitter is the combination of original message and CRC. Okay, if you get the CRC you have to include in the message, and now this message to be transmit, and again in at the receiver we perform a division operation for a received frame. Okay, this is your received frame. Okay, if and then we again perform a division, and here we are showing that if the reminder is 0, that means your frame or your received message is correct. Okay, otherwise it is a corrupted message. So now we take one more we take one example, then we get a more clear picture about the all the calculation process of the CRC, how to generate a CRC at the transmitter, and how to transmit a message with include the CRC, and if the message is received with CRC, then how to check the message at the receiver, and how to find out the reminder, and based on the reminder value how you identify the CRC, based on the CRC how you check the frame is received framework is correct or corrupt. So all these concept now I will discuss here in this example. So this is an example. So here we have to find out the CRC value. Okay, so this is the message this is a message we are transmitting, and this is a polynomial, divisor polynomial. So first we check in this polynomial is convert into the binary data. So we have to write this equation in this form, because in this equation some polynomial is missing. Suppose that x square term is missing and x to power 1 is also missing in this polynomial. Okay, so here if you observe here, so this is actually x to power 0. Okay, now x to power 0 represent the coefficient of x to power 0 is 1, and the next x to power 1 coefficient is 0, x to power 2 coefficient is 0, and x to power 3 coefficient is 1, x to power 4 coefficient is 1. So this is the polynomial binary data. Okay, so in here we observe how many bits in this data. So here 5 number of bits. So n minus 1 bits to be include, n minus 1 bits to be include in your original data. Okay, so this original data is already given. That means 4 extra 0 to be include in the original data, and this extra bit is only used for the error detection. Okay, this is known as a redundant bit, or sometimes it is known as a check bit. Okay, sometimes it is known as a check bit. So there is a divisor, and now we are this data to be right here and perform the division operation, and we have to check the reminder. This reminder value denotes the CRC, and this CRC to be included in the data. Okay, this reminder is nothing, it is a CRC. Okay, so we go for the calculation part. So we have already included 4 extra 0. Okay, 4 extra 0, and this is your original message. Okay, this is your original message. Okay, and this is the your divisor. Okay, that we generated from px. Okay, that is already given in the polynomial form is given, and we converted into binary data. Okay, so we have to divide here. So in the division operation, the operation is mod operation or XOR operation. So here we have to follow this method. Here if the bits are equal, your output is 0. Okay, in these two cases your output is 0, but if the bits are unequal, then output is 1. Okay, here we observe if bits are same, that means here get 0, and here also bit is same, that means here we get 0, and here bits are unequal, we get 1 1. Okay, so this is the value after division, and remaining bit, okay, remaining bits you have to write as it is. Okay, now the MSB, if you get MSB value is 0, so if you get MSB bit is 0, then this bit to be ignored. Okay, this bit to be ignored in the division operation. Okay, so that's why this is not included in the division operation, and here the same thing you have to write here. Okay, again here you see 0 into 1, 0 XOR 1, that means here 1. If bits are equal, then 0, then all bits are 0. So here what in remaining bit you write same as it is. Okay, so here the observation is some MSB bits are 0. Okay, so this is not considered in the division operation. Okay, so you start from the division from this bit. Okay, you start from the division in this bit. So here we write the data 11001. Okay, remaining bit okay, then we perform a division operation. Okay, then we perform a mod operation. So 0 XOR 1, that means 1, 1 XOR 0 means 1, and 0 means same bit, that means 0, and again same bit, that means here again 0 and here 0. So here what is here these 3 bits are MSB and this is 0, so that is not considered here. Okay, so you start from the writing the message from here. Okay, writing the message from here. Okay, so again we perform the XOR operation. So here we get 1, and this last bit, okay, only one bit is left here, we have to write here. Okay, so here there is no possibility to include our 5-bit message. So we have to stop this process. So we have to stop this process here. Okay, and we have already decided from the polynomial this bit is 5. So this is 5. So n minus 1 bit is we have included in the included in the message. So we have to consider only 4 bit. We have to consider here only 4 bit from the right side. Okay, so this 4 bit is this 4 bit means 0 0 1 0. Okay, this is the CRC. Okay, so this CRC we include in the message. This is the message and this is the CRC. Okay, now message and CRC to be transmit. Okay, and again we go for the we go in the receiver side and we have to perform some calculation. Okay, then we have to identify the frame is correct or wrong. Okay, so already this message and CRC frame is ready for the transmission, and now we come to the receiver. Okay, we received this message CRC algorithm. Okay, so now we come to the next question. In CRC, this is the your transmitted message, and here this is a generator polynomial matrix. From this generator polynomial matrix, we have to check how many bits are correct, how many polynomial is missing. Okay, so 1 into x to power 1, 0 into x square plus 0 into x cube plus 1 into x to power 4. So the binary, if you write the binary data here, so 1 0 0 1 1. So this is the binary data. So here how many bits? 1 2 3 4 5. Okay, so n minus 1 bit means 5 minus 1 bit to be included in the message, in this message. So this is your message 1 1 0 1 0 1 1 0 1 1, and 4 extra 0 to be included here, because this is the redundant bit, and this is your frame. Okay, now this complete frame to be perform a division operation. Okay, we know the divisor. Okay, so here we perform a division operation, the same concept. If you get MSB, please do not consider here. Okay, and here again here we get some 0 in the MSB, do not consider for the division. Here also you get some 0 0, that not to be considered, and here we get this reminder. Now here we have to only consider the 4 bit from the left side to generate a CRC. So the CRC value is 1110. Okay, now what is your original message? 1 1. Okay, your original message is 1 1 1 1 0 1 0 1 1 0 1 1. And what about the CRC? This is your original message, and now CRC bit is 1110. Okay, so that is the your transmitted frame. So here they are asking only the transmitted frame. Okay, if they said you have to check this transmitted frame, then again we perform a division operation on the receiver, and then we check on the reminder bit like that. Okay, so this is all about the CRC. So CRC is used for the error detection method. So CRC is actually detect the error in the data and the information transmitted over the network, including the CRC. And receiver, we are checking the reminder value. If all are 0, that means there is no error in the received code word. Okay, so this is all about CRC concept. So thank you very much.